Hello, everyone. Welcome to this session, which I think is going to be very special. I'm Krista Tippett. I was told to introduce myself. This is a live taping of On Being. On Being was on public radio for 20 years and until 2022, and now we're doing podcast seasons, mostly from live events, and so this will become a podcast. My producer, Chris Heagle, is here somewhere. And yeah, I should just do a shout out that I keep meeting people who think On Being doesn't exist anymore, but we're actually in the middle now of a 3-month cycle of new shows and also something we're calling the Hope Portal. And I'm excited to add this to a future season. I want to say, well, let me tell you what we're going to talk about, and just say that we're going to go a little longer today because this is a live taping of the show. If you need to leave at 4:50, please, I give you my blessing to stand up and walk out. But I'll probably go about 45 minutes up here, then open it up for questions for 15 minutes. I think there will be questions. And then come back to the stage where we'll finish out and kind of bring the show to a close. Gul Dolan leads the Dolan Lab at UC Berkeley since 2024. Before that, she was at Johns Hopkins. She's still affiliated with Johns Hopkins. And there, one of the things she was involved in was really discovering the nature of the critical period for social learning in the brain, and we're going to discuss that and explain what that means. She believes that this is a key to the transformative healing properties that are being discovered of plant medicines and psychoactive chemical compounds that are now that there's major research going on, as I don't know if everybody knows this, but at most of our major universities. I have walked into what I've come to think of as this parallel universe of research, of science unfolding. This past year in my life, actually through my life partner who's connected to this field. I first met Gul at a conference in Iceland just a couple of months ago on the science of psychedelics, where I just got this deep download on what is happening of the science that is astonishing. And then last week we were also at the same Science of Psychedelics conference in Denver. Gul is quite famous for a study she did on octopuses. I'm going to touch on that, but I really want to focus on human beings. And I think, my fascination, what I've pursued with On Being are the great questions of meaning as they are rippling through 21st century lives and through every 21st century discipline. What does it mean to be human? How do we want to live? And importantly, who will we be to each other? And it's been fascinating. These questions across time have traditionally been the domain of philosophers and theologians. And in this, as I've been building the show in this century, it's been fascinating to see scientists like social psychologists and very especially neuroscientists walk onto this territory, with their distinctive way of coming at this and uncovering it. Neuroscience is a young field, and I find neuroscientists often living in awe at what they are researching, pursuing, seeing. What I want to explore today is research and trials into psychedelically-assisted healing therapies, also real-world evidence of human beings who have been transformed, though they often have to go to other countries to get this treatment. Treatments for PTSD, for long-term addiction, for treatment-resistant depression, and even now for conditions like Parkinson's disease and strokes. I'm curious about what we're learning about the brain and the brain's capacity to heal, and actually the human capacity for transformation through this new science around psychedelics. I want to acknowledge right up front that like every powerful thing, this one can cut in both directions. It can touch on the deep light and the deep dark of the human condition. And I think underlying all the important research, and certainly the research you're doing, is a desire to understand how to create settings for maximum beneficial human effect. We're also going to get into the fact that there are constituencies forming around this science and this phenomenon that defy every division in our culture right now, all these divisions and fractures that ail us. So this is not actually just about healing at an individual level, but there are really fascinating societal implications. And we're going to get to that, and that is why we are going to need more than 50 minutes today. So Gul, you grew up in Texas. Your grandparents were in Turkey. Were you born here?
Yeah, I was, let me move this a little closer. I was born in New York, in Buffalo, New York, and then my parents were both Turkish doctors, and they moved to the United States hoping to get a little extra training, and then they were planning to move back. But then political things conspired, and they ended up staying longer, and then we moved to Texas, and then I just basically grew up in Texas. And my whole rest of my family was still in Turkey, and so my mom never wanted to lose her connection back to Turkey, so we would go back every year and visit family and relatives.
And there were a lot of scientists in your family, right? Your grandmother was a zoologist, is one that I read about.
Yes, that's right. My grandmother was a zoologist. Both my parents are doctors. Actually, I think it's more fair to say that the family is full of academics. So, especially on my mother's side, everybody's, an academic of some sort, pretty much.
So, as I just said, I think that the questions neuroscience is asking right now are among the most fascinating and revelatory of our time. And also, neuroscience is such a young field. And so you are on an emergent cutting edge of an already very, essentially still emergent field. You also went to medical school. Is it right that I'm curious about how you walked into this, and it sounds like you initially were working on autism. Is that right?
Yeah, so actually it started a little before that. When I was undergrad at Duke, I had kind of concocted in my mind that I wanted to do a triple major, and they said, no, that's not allowed. You have to design your own major. So I designed a major that was a combination of neuroscience and linguistics and philosophy and art, and it was comparative perspectives on the mind, and sort of getting at this idea that, and at the time the neuroscience department had just formed, and so I was really interested in understanding the brain and consciousness actually from multiple different perspectives. And it wasn't until I think my sophomore or junior year that I took a class called Drugs, Brain, and Behavior. And we learned about all kinds of psychoactive drugs, but the group of drugs that really caught my attention were the psychedelics. And so these are drugs that cause an altered state of consciousness. And when I saw the picture of the LSD molecule right next to the serotonin molecule, and there was so much structural similarity, and I understood that basically people were taking this pill, this molecule, and dramatically altering consciousness just by this molecular physical interaction. I basically completely pivoted towards neuroscience at that point, because I felt like this is the way we're going to someday answer the big questions about consciousness.
You did. You really felt that.
I did. But at the same time, that was in the late 90s, and psychedelics research really wasn't considered, something to do with your career, right? It was sort of like, okay, I understand, blue-haired girl, you want to study this, but, you need to know some molecular biology, you need to learn whole cell patch clamp electrophysiology, genetics. These are the things that make us serious neuroscientists. So after I finished college, I did take one more little segue. I had this idea in my head that I was going to be, a National Geographic explorer type of scientist, and so I convinced a bunch of archaeologists in Turkey to let me be the artifact photographer for their excavation of an 1,100-year-old shipwreck. And I did that for about 4 months, and about halfway through the summer, on our boat rides out to the shipwreck, I found myself explaining to all these archaeologists all about neurons and synaptic plasticity and transmitters, and I realized, okay, no, I really have to do this. And so I I turned down a job as a photographer and took a job as a research technician at Columbia University. I finished up some extra coursework and decided to do an MD PhD. And when I started the MD PhD program at Brown, and then eventually I moved to MIT because my advisor moved there, I wanted to work on something related to autism, related to consciousness through this theory of mind question that I had. And so I focused on autism as a graduate student at MIT.
So I've heard you speak a couple of times, but in settings where people are kind of in this world and actually with a lot of other scientists present. So I said to you, I want us to kind of spell out what we're talking about in terms of substances, because culturally we know some things, but I've learned that there are a bunch of distinctions I didn't have. So MDMA, which is a substance you've worked with very intensely, was created in a lab in Germany in the 1960s, but kind of its properties were kind of rediscovered and revealed. These properties having to do with the brain and consciousness by Sasha Shulgin in the 1970s. But MDMA, many people will know as ecstasy, if we're like recreational use or party use or Molly. So what is the difference between those three things that I just named?
I would say they're the same. Different partygoers will name them different things, but essentially they're all 3,4-methylene deoxymethamphetamine, MDMA, and they're all variants of that same compound.
And as we'll discuss, though, the properties its capacities are very different in the kind of controlled therapeutic setting that you create. In fact, setting is everything.
That's right. And before we kind of jump to that, I would just also say there's a little bit of a debate in the field about the naming of psychedelics. So I prefer the umbrella term that was used by Sasha Shulgin, who you mentioned, he was a chemist. He worked at Dow Chemicals for many years, and then when Dow Chemicals closed down their psychedelics research department, he moved his research lab to his own property in Lafayette in California, and he and his wife, who was a therapist, essentially researched and invented and resynthesized over 200 compounds and then tested them on themselves and other people in their research group. And Sasha Shulgin called, all of these drugs, including MDMA, psychedelics. And psychedelics have been kind of broken up into different subtypes. So MDMA is unique in that it's one of the better-known psychedelics that has an empathogenic property, meaning
heart opening.
Yeah, heart opening. People, use it in a recreational setting, and they'll do things like 30-person cuddle puddles. They really like to touch each other and be around each other. They will describe all kinds of sort of very pro-social effects of these drugs. But like all psychedelics, as you mentioned, they are very much dependent on the set and setting. So if you take MDMA in a recreational setting, it's a very different effect than in a clinical setting. The other psychedelic categories that I should just mention are the dissociative psychedelics like PCP and ketamine, what some people call the classical psychedelics, but I don't use that term. I prefer the hallucinogenic psychedelics. Those are ones like magic mushrooms, LSD, mescaline, ayahuasca, DMT. Those are the serotonin or hallucinogenic psychedelics. And then the category that's getting the most attention recently is ibogaine, which is an onirogenic psychedelic, meaning it induces a dreamlike state that lasts for a very long time. And that's the one that's showing the greatest therapeutic efficacy in addiction and, really entrenched post-traumatic stress.
And we'll talk about that. And so some of these are made in the laboratory altogether, and then something like, like mushrooms there's psilocybin that there can be synthesized. Right. And ayahuasca, the psychoactive compound is DMT, which can be synthesized. And ibogaine comes from the iboga tree that is native to Gabon. Can ibogaine also be synthesized?
Yes.
It's being so powerful right now, so we'll talk about that one. I think I just want to say it. It's like, let's just raise our awareness here that drugs are such a massive part of our lives, right? We give our children Ritalin. I don't know what percentage of that, all those of us in this room, including me, are on some kind of SSRI. We drink our caffeine in the morning. We drink alcohol all the time. So this idea of altering our consciousness with substances is actually very commonplace. These are just other substances, very powerful ones. So I've heard you talk about how what we're learning about these substances and their therapeutic properties is really a departure from a lot of the things that neuroscience understood. So talk about that, like how you're really walking down a different path that might have surprised you even.
Yeah, so I think that you sort of touched on it. You know, we are awash with psychoactive substances in our lives, many of them prescribed. And part of that is because basically since, antibiotics cured syphilis, neuroscientists and psychiatrists and neurologists have dreamed that there was a pill that you could take that could cure the disease and one and done and you're finished. And in the 50s and 60s, there was a big push to develop new chemicals and compounds for neuropsychiatric disease. And the SSRIs, the selective serotonin reuptake inhibitors, kind of came out as the big winners of that push. And the model that was used and is still considered sort of the gold standard and what most psychiatrists are trained in is that if you are depressed, it's because you have a biochemical imbalance in your brain with serotonin, and all we have to do to fix your depression is change that biochemical imbalance and restore it. I think what psychedelics are teaching us is that that is not right, and that instead, the reason that psychedelics, after giving 1, 2, or 3 doses of these and pairing them with with therapy, then you can restore the ability of the brain to learn. And what you learn under those conditions of psychedelic assisted therapy, that's what gives these medicines their durability, even though you only took it 1, 2, or 3 times. And this is a fundamental shift, and I think is actually causing a major sort of rift in the field, because all of the ways that we develop drugs, all of the established ways for raising money for clinical trials, which can be very expensive, $250 million is not an abnormal number for a phase 3 trial. They all build on this economic model, which requires patenting drugs, medicalizing people for life, and basically and the psychiatric model is you give a medicine and then the patient just takes it forever. And that's considered okay in psychiatry. That's good enough. The symptoms go away. People feel better.
And SSRIs don't have a great success rate.
They, for people who have, a family history and it's really, really severe depression, that's how SSRIs were approved. But since then, they've been kind of given out like candy. They've been extended to mild to moderate depression. They've been given to people who don't even really have a true definition of depression. Then they've been given to kids. The formulations have changed, and so now people trying to come off of SSRIs are experiencing massive withdrawal, which makes it impossible for them to come off of them. And so, it's a real mess that we've created, in my view, and I am hopeful that psychedelics are going to be the answer. But I will say that the reason that this is still a major debate is because until we sort of came up with this mechanistic explanation, I think most neuroscientists, establishment neuroscientists, were still running to the serotonin explanation. The biochemical explanation.
And the mechanistic explanation, and is it the reason you couldn't fix things just by knowing the biochemical is because actually the brain is is fixed.
Yeah.
And yet, there is this thing called the critical period that has been observed forever, right? So why don't you talk, because that is really this new frontier, and you are a key person who's opened that up.
Yeah, so the notion of critical periods was actually, that phrase was coined in 1935 by someone named Konrad Lorenz. And he was an ethologist, and he described this imprinting behavior in gray-lag geese. And this is a behavior where within 48 hours of hatching, these geese will form a lifelong attachment to whatever's moving around in their immediate vicinity. So typically this would be their mother, but if their mother's not available or around, it could be a surrogate mother, it could be a crazy scientist like Konrad Lorenz himself, or a mechanical airplane, and they will form this attachment, and it will last their whole lives. And you might have seen these pictures on the internet of, Konrad Lorenz being followed around by little geese, and that's real. And so he described this, but ever since then, we've discovered dozens of other critical periods. So critical periods for language, critical periods for organizing the brain's visual circuitry, critical periods for learning motor functions. We suspect there are critical periods for developing your personality. And then my lab discovered this critical period for social behavior. And I can get to that in a second, but the reason there's so much attention in neuroscience around critical periods, just to give you a sense, there are about 7,000 papers written about critical period mechanisms. If you do a quick PubMed search, 3 Nobel Prizes have been given. And the reason we're so obsessed with it is because we've understood that the reason we're so terrible at curing diseases of the brain is because by the time we get around to intervening, the relevant critical period is closed. So the classic example of this is, imagine that you were born and you had cataracts in both eyes. If you don't have those cataracts removed before the age of 5, you will be blind forever, because even if you remove them after that age, the visual information is getting through the eyes, but is not able to be processed properly by the brain.
Because there was a critical period for you to develop that visual capacity.
That's right. And so neuroscientists have dreamt about having a way to reopen critical periods and then be able to treat diseases of the brain.
And I've heard you use also this example of language learning, which we also know, like if you have 4, 5, 6-year-olds who are living in a different country, like they can learn multiple languages and become fluent, and then at a later stage it becomes very hard for most of us.
That's right. And the reason this is set up like this is because there aren't enough genes in the genome to encode every single behavior that we might need, right? So rather than encoding a single gene that encodes, let's say, English, what the brain encodes, or the genome encodes, is the ability to learn whatever is relevant to your environment. So rather than just one human language, we can learn any one of 7,000 possible languages, whatever is being spoken in our environment. And so that's great for someone like me because, if I had been born in this country and we only had a language gene, then, I'd be speaking Turkish to you right now with a translator. Instead, I speak, fluent English.
Yeah. So, there's just amazing language looking at describing what can happen in these therapeutic settings when you pair MDMA in the context of psychoanalysis. Language like, what can happen is that trauma is rewritten, that personality traits are renegotiated.
Yeah, there's a lot of excitement about this, and when people talk about last summer, there was a big attempt to get Lycos, the company that was running many of these studies for MDMA-assisted psychotherapy for PTSD. It's okay. They tried to get the FDA to approve this application, and it got rejected. And some of what I heard from the advisory committee that was making the recommendations to the FDA was that this just seemed too good to be true. They were getting patient reports where people were the results were twice as much recovery from PTSD as any of the existing therapies. And I think the FDA got really nervous. They were like, this has to be apocryphal. There's no way.
And total and enduring recovery.
Yeah, lasting for
At all
over
of
a
these
year.
science conferences, there
Right.
are veterans who are transformed human beings, and it feels like a miracle.
Yeah, and so I think part of the reason that they rejected is that they didn't feel like they understood why this should be happening. They, were looking for other reasons, like maybe the trial was biased, maybe the people who were running the trial were picking people who were already inclined to wanting psychedelics to work. They came up with all of these different reasons. But, for me as a neuroscientist listening to that, this is exactly the kind of recovery that you would expect if what you're doing is reopening critical periods. So, I'm quite excited about it, but I will say that, the studies that have been done to try and, in this formal setting, to try and get FDA approval, the number of patients in those pharmaceutical company trials is still relatively low. So we're talking about 60, 100, maximum 150 people, right, per study. Whereas you have these other anecdotal reports from people going in to not studies, just where these policies have been changed. So, thousands of people going in.
Like 10-day treatment programs.
Exactly.
In Mexico, there's quite a lot
Mexico
of it. Yeah.
and Brazil, Costa Rica, and, more and more in Australia, where they have decriminalized and you can treat with these drugs with a medical license. And so, as we're getting more of this kind of real world data, we're gaining confidence that this is actually real
Right.
and happening.
But science is not used to making or the FDA doesn't make decisions on the basis of real world data.
Yeah.
And you're working with illegal substances, so it's a bind. There's something fascinating about the distinction between these different substances and the duration of the time that your consciousness is altered, for want of a better way to describe it, and the opening of the critical period. And I saw a chart, I showed a chart in Iceland. So one of the reasons Ibogaine, which I think I hadn't heard of, and I think fewer people have heard of, is so special and getting so much attention is that it has it seems, if this is right, I know you're always saying this is a hypothesis, but if what's happening is it's opening the critical period in the brain, so with ketamine, it's a very short duration.
Right.
But with MDMA, it's a bit longer. But with Ibogaine, this critical period where we are capable of learning new things, and I mean, if I understand it also, like kind of the brain reconstructing itself before the damage was done.
Well, I mean, that again depends.
Is that a way
on,
to say it? I don't know.
That sort of depends on the context. So
Right.
the way that I always frame this is that if you take MDMA and go to a rave or an all-night dance party, you're unlikely to cure your PTSD. You really need to pair it with the right context. So the transformation happens when you're sort of in that psychedelic altered state and you are addressing the issue or the problem and you're learning to see it from a different point of view. Now, we started getting interested in this duration because we noticed that there seemed to be some correlation between the duration of the therapeutic effects and the duration of the acute subjective effects of these psychedelics and the durability of the therapeutic effects. So ketamine, for example, is a very short-acting psychedelic. It lasts about 30 minutes to 2 hours. And originally, when people were using ketamine, the way that it was approved by Johnson & Johnson was really as a fast-acting, next-generation SSRI.
Yeah.
And so people were
ketamine is legal.
It is, yeah.
It's the one of these that is legal.
And so it was being used without therapy. People were just giving it, but within a week, people were feeling depressed again and having to go back and get another. And we wondered if there was some correlation between the duration of the trip and the duration of the critical period open state, and there is. So ketamine keeps the critical period open for about 48 hours. By a week, it's closed. MDMA and psilocybin keep it open for about 2 weeks, and by 3 weeks it's closed. LSD, which lasts a little bit longer, keeps it open for 3 weeks, and then by 4 weeks it's closed. And Ibogaine, which is this extremely long trip, keeps it open for at least 4 weeks, and we didn't test any further out from that. Now, just to be clear, that open state feels good, right, we think, and that there is some euphoria associated with opening at all, but the way that I think about it, the way our hypothesis frames this, is that that window of time is your opportunity to lock in whatever insights, whatever new habits that you're trying to form. That's the time to learn it and really get it locked in. And if you don't get it locked in, then you might need to come back and reopen so that you can.
In these therapeutic settings, I mean, you're using that month, right? You're using those weeks. It's assisted.
Ideally. Although I think that, there is so much enthusiasm for psychedelics right now. I was just down in a clinic in Mexico, and many of these veterans were coming down having heard all the hype and expecting that they were just going to take the psychedelic, they were going to address the trauma that they experienced in war. They knew exactly which trauma it was that they were going to see. And then the next day, they were just going to give up being a heroin addict and everything was going to be fine. And almost every single veteran who I talked to had basically not that experience. So what they instead were experiencing was, oh, I realized that the instigating event happened, when I was 5, and everything else in my life kind of led me to that. I went to, I joined the military to kind of compensate for this original trauma. I did all these other things that traumatized me more, and I realized that my heroin use was essentially a way of compensating it. And they said almost, many of them said, the therapy or the work actually began the day after the trip, because it was the day after the trip that I had to take those insights that I had and build them back into all of the ways that I interact with the world, all the ways that I perceive myself, all the ways that I reach for this drug when I'm feeling bad about myself or feeling bad about the world. And they understood that if they didn't kind of practice this new way of interacting with themselves in the world, that they would very easily slip back into the heroin use. Mm-hmm. So it's not a magic pill, it's learning, and learning is hard. It takes practice and work.
And also, what is distinctive about Ibogaine is its transformative potential, especially for, as you say, not just garden variety addiction, but heroin or opioid addiction or severe PTSD. Also, Ibogaine is not something you take and go to a party. It can kill you.
Yes.
You have to have heart monitors on. That cardiac arrest is a real possibility,
That's
danger.
Right.
And I want to talk about the cautions also with this. Yep. And that the brain in that critical period, that open state, is, as the brain of a child, is vulnerable and malleable. Yeah, and also that neuroplasticity, I've been known to say, when I first heard neuroscientists, actually, because neuroplasticity, this is new knowledge, right? Yeah. And I remember 20 years ago talking to people, it was kind of this new discovery. It was thrilling, right? To think, because when we grew up in the 20th century, you learned that at some point the brain stopped developing. Mm-hmm. Like you're 16 or 18 or 25, and you're not really going to learn anything new or be anyone new. And that is out the window, right? Mm-hmm. We learn that, but you also, that neuroplasticity also can go both ways.
Right. So this gets thrown around a lot, and especially the chemists are pushing this idea that psychedelics are inducing plasticity. And I ask people to really exercise caution around using that word, because not all plasticity is good plasticity. We know that almost every drug of abuse, cocaine, heroin, fentanyl, alcohol, nicotine, they all induce massive amounts of plasticity. And this plasticity is hyperplasticity, and we think it's sort of the mechanism that enables those addictive drives to get locked in. And so going back to the language analogy, you've taken a pill, And instead of being able to, so with cocaine, for example, the language you learn is, I love cocaine, I love it here, I love it there, I love it everywhere, right? And you just learn that one thing a lot, right? And so that gets locked in, and that gets encoded as hyperplasticity. In contrast, what psychedelics seem to be doing is not just, hyperplasticity. Instead, what they seem to be doing is enabling a change so that the same stimulus is able to induce plasticity more easily. And that is called metaplasticity, the plasticity of plasticity. And this is important because, when we start really diving into the mechanisms and who we want to, give psychedelics to and who we don't want to give psychedelics to, I think, these opposing types of mechanisms, makes it make sense that metaplasticity is going to enable some flexibility around that super well-learned heroin addiction. But for example, we have some evidence to suggest that people with autism, have part of the pathogenesis of the disease is that they have a failure to close critical periods properly. And so we want to be extra careful in people with autism, schizophrenia, which has some genetic overlap with autism, in giving these medicines.
And there's a profound awareness and responsibility, I think, in the field also, that we are partaking of, in part, with the plant medicines, especially something like ayahuasca, medicines as they are known in those places, that they are rooted in place and traditions and peoples. I think one of the interesting things for me about, being at the Denver conference or in this world, and I'm sure we got to this as Westerners, but there is a reverence for the elders, the cultures that have tended these, known about this healing and used it ceremonially. Maybe I want you to hear what you have to say about that, but that it felt to me refreshing to see that. Again, I don't know, I'm sure that wasn't there at the beginning when we were, I don't think Timothy Leary cared about where anything came from. But there's also this interesting study about how important the setting is, and about the Bruce Alexander work.
Okay, so let me just go back to the notion about respecting Indigenous use and traditions and not trying to co-opt their traditions. And I guess I'm of two minds of this. One is that, of course, we want to be respectful of these traditions, but at the same time, when I first started working on this, I got a lot of pushback, like, why do we need to understand the mechanism? We know from, hundreds, if not thousands of years of, indigenous use that these medicines are powerful and they work, and we have all this, underground therapy work suggesting that, they're effective. We don't need to know the mechanism, we just need to demonstrate it to the FDA and get approval. And as a neuroscientist who studies mechanism, I hated that idea. I was very angry at that sort of notion. And my explanation was, listen, we can't just pluck something from another culture and expect to use it the way that we understand disease, the way that we understand illness, the way that we understand healing, without putting into that mechanistic context of our own. The other thing that I heard recently, which I loved, is, for the plant medicines, surely we have borrowed from other cultures, but MDMA and LSD and ketamine and PCP are synthetic compounds that we are the knowledge keepers of. This culture invented them, and this medicinal tradition and this chemical tradition invented, and we are the stewards of it. And so it is our responsibility to understand how they work in our medicinal context, in our neuroscience framework, and otherwise we're going to possibly do great damage or miss big opportunities for, what else we might be able to use them for in understanding the way that we conceptualize the brain for our types of diseases.
There's a calling to be good stewards, to be good elders, right? To be good ancestors, as Carl Sagan said. And also, we have to acknowledge And I think this is a hard thing for people to talk about in this field because the healing, the magnitude of the healing is so astonishing and beautiful. And, they're good for PTSD and addiction and perhaps Parkinson's and strokes, and I think are not great. There's no cure for narcissism, right? And a narcissist,
Right.
Charles Manson gave LSD to his followers, and there are some billionaires we might mention who
Right.
famously remain narcissistic after using a lot of ketamine.
Yeah.
And by the way, also, meditators can be great narcissists too.
That's right.
But that, because these substances are so powerful, that's...
Well, so what I would say is, sort of thinking about it in our framework, just let's talk about narcissism in particular. At least when I went to medical school, the working sort of understanding of narcissism is that, narcissism is totally normal and required when you are 3 to 4 years old. You need to be a narcissist in order to get your parents to give you what you want and your grandmother to give you the lollipop that you want, right? You need to live in that world where everything revolves around you because humans are altricial species. We cannot survive without care. So that's appropriate. If you get injured early or you don't overcome that stage of development, you can get stuck in that narcissistic pattern well into adulthood. Now think about what I'm saying about what we're doing with psychedelics. We are reopening critical periods and returning people to that childlike state of early development. We are inviting people essentially to become more narcissistic in their worldview. We are asking them to be more flexible in their worldview. We're returning people to a state when they believed in things, right? Like very few adults believe in Santa Claus, I hope. I'm not ruining it for anybody here. Exactly. I actually, just funny sidebar, I said this to a friend of mine's teenage daughter, and she laughed it off, and then later she told her mom, Ghoul was joking, right? Like, Santa's real. So I'm always a little careful. I don't want to make assumptions. But anyway, we're returning people to this stage of sort of flexible belief systems where they accept a looser, let's say, rule set for causality. We have to be careful as we understand what these psychedelics are doing to give people the right healing context so that they don't, they don't lose track of it. And it's also another reason that I'm worried about trying to treat psychedelics like they're next generation SSRIs, right? So ketamine therapy is a good example. Since when it first got approved, there have been now a lot of concern raised over people having to go back every week, taking it for, sometimes years at a time, developing some more of these personality disorders, and also developing abuse liability around ketamine, right? We say that abuse liability is low for MDMA if we're giving it 3 times in a clinical setting. But if we're being forced to give them every 2 or 3 weeks, the situation could be very different, and we just haven't collected that kind of data. So, and then the point you made about Charles Manson, I think, is also an important one, right? We are very amazed by psychedelics and what they can do, but I believe that psychedelics are sort of, they're like any learning. Depending on what you provide, that's what gets learned. There's no valence to it. It's not good or it's not bad. It's just neutral. And so if you are trying to overcome PTSD and you get exposed to a good therapist, you protect yourself after you had the MDMA, you don't go back into a home where you're still being abused. Those are all good outcomes. But if you take these psychedelics and spend time with, a psychopath or a narcissist or an abusive person, you could be inducing a kind of lasting trauma that is going to get locked in while you're still in this vulnerable, sensitive state. And so this is another classic example of how understanding the mechanism can teach us a lot about how to use these medicines, even in a therapeutic setting, appropriately.
Okay, so I'm going to open this up for questions for about 15 minutes. And then at the end of that, we'll come back up here and finish. And we haven't talked about the octopus, so if anybody is really interested in that, you can ask that question. There's a hand right here and right here too. Yeah.
Thank you.
Oh, there, a microphone, yeah.
Microphone's
Here we
coming.
come.
Okay.
Thank you. That last comment you made me really want to ask this question I've been thinking about the whole time.
That's what you were going to ask.
It sounds like the training of the therapists who guide people through this is so vital, more vital than just even general therapists. And how does, beyond the drugs getting regulated, how would that be regulated? Because it sounds like that would be like a whole nother ball of wax is part A. Part B, from a like a system standpoint, it also sounds like it's a very difficult medical intervention to scale because of how highly intense the intervention is. So those are my two questions.
Okay, those are great questions, and I think they are very much coming from the state of things right now and the way that psychiatric illness has been treated by the sort of pharmaceutical industry, right? We've come to accept this as a limitation, that we're going to have this huge burden and it's really hard. But if you go to, let's say, neurology, which is where we're next focusing our attention, nobody would ever say, the interventional radiologist has to do this crazy long surgery to remove your blood clot that caused you to have this stroke. But I'm sorry, occupational therapy is just too expensive, you go on home. That would never happen, right? So in neurology, we have a totally different paradigm for understanding the importance of the learning combined with the intervention. And it's not a problem in neurology. Nobody says in neurology, how are we ever going to pay for this intensive intervention and this intensive therapy? How are we ever going to train enough occupational therapies to give people this medicine, right? So I'm hopeful that if we can demonstrate our theory, especially in the stroke trial that we are starting hopefully within the next month, we can help establish this idea, this framework for understanding how psychedelics are working in neurology, where this is already accepted, and slowly bring psychiatry and psychological illnesses over to that way of thinking. Now, the first part of your question is also important. This is a little bit of a debate right now. We don't know that there has to be a specific kind of psychotherapy that requires a specific kind of intervention. There are a lot of different therapies that seem to work, and there have been review articles written about this by psychiatrists who emphasize that the most important thing is that you provide a framework for the patient to understand their healing in the therapeutic setting. So whether you use cognitive behavioral therapy or Freudian analysis doesn't seem to matter much, as long as you provide people with a framework for understanding the transformation. So I think there's a lot more research that needs to be done to understand exactly how that's happening. And I think that we can't get lost scared of this challenge, because it's potentially very exciting, right, to try and figure this out with something that actually works.
It's striking at these gatherings of scientists and practitioners and activists and funders. For example, there's a young woman named Juliana who, I'm not, she's somebody who, brilliant, became addicted to opioids, spent time in prison. Her life was saved. She did ibogaine treatment in Mexico, and she never wanted opioids again. And And at all of these conferences, she's on stage saying, like, her whole life's mission now is that the quality of the training has to be so high. So, you know, and so she's out there, like, there are these networks of training being created because there's this understanding of that.
Right.
Yeah.
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 It's a little off topic, but
Yeah. Yeah.
but you're the brilliant scientist that can answer a question that the last panel I asked couldn't answer. It was on AI and education, and my fear, of course, of a lot of it, as a writer, et cetera, we struck on this, was that the person on the panel said his child of 3 was using AI. In the critical period that you're talking about, when is the brain forming and learning how to learn, and using AI would stop that process?
Yeah, I don't think AI will stop that process. I think what a person who is getting a lot of learning through AI at age 3 is getting essentially a degenerate, sort of limited social interaction. So human beings are incredibly social. You know, I used to have, my lab studies social behaviors, and I used to have to harp on about this and provide data about mortality rates in lonely people. But I think we all learned that lesson in pandemic. I don't have to belabor the point now. We are incredibly social. It matters to us that we we don't learn as well if we're learning from, even on Zoom, even on computer monitors, because it's degenerate social information. We don't have the olfactory cues, we don't have the touch cues, we don't have, you know, the ability to move through the social environment, right? And so I think that we already know that all of these technologies that were sold to us with the promise of people are going to be less lonely because they can check on their friends on Facebook, that's just going to, and that made things worse, right? Because, you know, when you put something up on Facebook or Instagram or whatever, I don't have social media, but, you know, I am aware of these things. You are providing essentially a very glossed over version of what's going on in your life. You're not allowing the other person to smell your fear and to know your pain. And so rather than it being an opportunity to develop empathic skills and reciprocity and helping, you're learning competitive fear, anxiety, right? And so I think that these technologies that are being sold to us, AI companions, and, you know, they're going to help with, you know, the healthcare crisis and helping with elderly, I think that they are nowhere near, you know, what a normal social interaction is like. And on the other hand, the reason that we have critical periods is that we're adapting to whatever environment we're in. So Alison Gopnik, who is a famous,
yeah, she's great.
She's a famous child developmental psychologist, actually, in my department at Berkeley. And she has written several books on child development and all of the fears that we all have over, you know, new technologies. And she says, you know, every generation wrings their hands over the new technologies. And she gives this great example of, you know, how there was this new technology that Plato was very afraid of because, you know, paper was going to make it so that people weren't going to be able to memorize epic poems anymore, right? And so
He was right.
he was right, and yet how many people are that worried about not being able to recite the Odyssey? Like, not that many. So I think, you know, the reason that we have critical periods is because the environment that we're born into might be very different than what our parents had. And maybe the reason that we have, you know, multiple cultures using these psychedelics is that we live a long time and the world changes in our lifetime, and to be able to reopen and learn and maybe take an AI class may be the reason that I'm not, generally speaking, very optimistic about AI, but, you know, I'm middle-aged now, and so I'm allowed to be a little skeptical of the new technologies.
Why don't we take a few questions, and then, you know, we can just see what. Here's one up here, and then where's the microphone?
I think there's some more right here too.
And I'm sure there's some in back. I'm not looking at.
I'll start.
Okay, you
over
start.
here.
Yep. You start.
I have a question for you. You're talking about clinical use of psychedelics. What are your thoughts on microdosing and using psychedelics in the non-clinical situation?
So we have looked at this, and microdoses do not reopen the critical period. And I can't 100% say whether or not that is, this is of psilocybin. Whatever it's doing is just below our detection threshold. I should also say that microdosing mechanisms can be very different depending on psychedelics. So, for example, people develop very quick tolerance on LSD and psilocybin microdosing because those receptors get internalized. On the other hand, ibogaine, it seems that you don't develop tolerance to microdoses of ibogaine in the same way because it gets stored in the fat. So, there might be differences here. All of the clinical studies trying to look at microdosing suggest that it's mostly placebo effects at this point. That being said, I have nothing against macrodoses being used for optimization. And I do think that there's mechanistic overlap, for example, between psychedelic-induced mystical states and mystical states that have been used by religious practices like, meditation and going and living in a cave for a month and, sound baths and, these other deprivation techniques, because we know that deprivation in this way can also reopen critical periods. And so I do think that there's some restorative power in being able to do this in a controlled way for personal growth.
Okay. Yeah. Here.
First, thank you so much for your work. For me, this is quite personal. I have Parkinson's, and I have several loved ones who are in treatment now for depression with ketamine. So a two-part question. One is, can you talk a little bit about how the mechanism for Parkinson's might work, what the timeline might be, what intervention might be used? And then secondly, given the short time duration of the critical period for ketamine, how might one in treatment optimize their strategies to make that work?
Yeah, so I have to say I'm a little bit, I think the Parkinson's data is still very much, equivocal. There are some data that suggests that it's really good for the depression and the psychiatric part of Parkinson's. It's pretty clear that it's not actually reversing the, the death of the dopaminergic neurons in the substantia nigra. And it's not clear that even if there's some motor recovery, that would have anything to do with the critical period mechanism I'm describing, right? So just to be clear, the critical period mechanism accounts for, I think, a lot of what we're seeing with psychedelics, but not everything. So the headache, there's a lot of increasingly good evidence that psychedelics given once or twice can rid somebody of cluster headaches permanently. And these are, suicide headaches, really, really bad headaches. And I think that that's a direct action of the psychedelic on the blood vessels. And doesn't necessarily have anything to do with this critical period mechanism. Some people have proposed GDNF or BDNF, which are nerve growth factors. I think I recently went to a conference which suggests that that's unlikely to be the case, and I just urge people to be cautious about these kinds of growth factor type explanations because, BDNF is brain-derived nerve growth factor. Implicating BDNF in some pathological or or curative mechanism is like saying the brain is involved because basically everything involves BDNF. This conversation is causing BDNF to be released in your bodies, right? Like it's implicated in addiction and it just doesn't have the explanatory power that I would require. So I think the jury is still out on Parkinson's. With ketamine, again, I think that the way that people are showing improved durability with ketamine is to pair it with therapy, right? So if you give ketamine and you don't give therapy, at 2 weeks out, your effects look about the same. But if you give ketamine plus therapy and you compare out, a year later, that group is doing much better and they have this persistent effect compared to the people that are just getting ketamine by themselves. And so
also, I think that rates of success for treatment, what we call treatment-resistant depression, which is just SSRIs don't work, is quite high with that kind of extended ketamine treatment.
Yeah, I mean,
Yeah.
I mean, the data, so the ketamine clinics are sort of collecting this data, and, you know, they're getting mass amounts of data, but they're still slow to publish because they, you know, want to really do a good job of looking all the way out. But so I'm sorry I don't have better news on that, but that's where we're at.
Okay, one more question. I'm going to take it here.
Thank you so much. My question is about actually just the journey to more social and cultural acceptance of this work. Obviously, there's much work to do more research to understand the efficacy. What else do you think needs to happen to actually change the cultural narrative?
Well, I mean, I think some of it is time. I do think that we want to give people the opportunity to learn about it, but also, you know, I think you brought up a great point about ibogaine. So the reason that ibogaine is getting so much traction right now is because people are excited about the idea that it's not recreationally used, right? And so conservative states like Texas, you know, are just devoting a huge amount of funding. They just got a bill approved to approve $50 million in research funding for ibogaine research in Texas. And this is because the conservatives understood that if they can kind of pitch this as a dangerous, difficult treatment, a medicine that people aren't using, recreationally, it was much easier to convince conservative governments. Because I think a lot of the conservative governments are worried that this is, you know, this push to talk about the medical efficacy of psychedelics is sort of being used in the same way as the sort of thin edge of the wedge that happened in cannabis. And I think that there's a lot of concern in conservative states that that's what's happening with psychedelics. So ibogaine is sort of well positioned to allay those fears. But I also am nervous about, you know, the rah, because I am very enthusiastic about psychedelics. I think they're doing this incredible thing. But I think if we overdo it, if we sell this idea, first of all, there's going to be a huge amount of disappointment. Second, we're going to give the wrong impression to people that, you know, this is a miracle pill. And then when it becomes sort of less criminalized, people are going to take it and assume that it's totally safe and they can do whatever. And, you know, there are cases of people who have overused, who have, you know, tried to do this work on their own without, you know, proper therapy and support, who've ended up committing suicide because they just couldn't handle all the trauma that they brought up in doing this work solo. So I want to be measured in the way that I'm enthusiastic about it. And if that means that it takes a little bit longer to get this approved, then fine. Because I really, really, really don't want to set us up for the next fentanyl faceplant, right?
Mm-hmm. Okay. Yeah, and so this kind of leads into something. One thing I want to talk about is the counterintuitive kind of parallel universe of support that is forming for this. So last week in Denver, at this, I don't know, there were probably 8,000 people there, the MAPS conference, Science of Psychedelics. Rick Perry of Texas spoke. He's behind getting the $50 million for ibogaine research in Texas. He's part of something called Ibogaine America for America, or America for Ibogaine.
It's called, yeah.
Together with this visionary Appalachian activist who's, you know, been surrounded by opioid addiction and sees this as transformative, and they are going to try to get every state to match in millions of dollars. I moderated a panel with former Senator Kirsten Sinema and Tim Ryan, so she's in Arizona, Ohio, Senator Bergstrom, who's a former military general, a Republican, also who has seen the transformative effect on veterans. So there was this bizarre, I mean, it felt bizarre that psychedelics was making this bipartisan, not just dialogue, but like this shared passion for making something happen, and actually for making healing happen.
Right.
Also, I thought, you know, the cross-generational, like there's young energy and there are the elders, and there's a real regard for like the elder scientists, for example, and the elder activists. I don't know, does that strike you as in this world? I felt like if people could just see this was happening, it would kind of give you hope, just that it's possible.
Yeah, no, it's really exciting, and I know where that enthusiasm is coming from. I mean, I went to medical school, and I never did a residency because I just felt like all we were doing all day long was taking down people's traumas, taking down people's injuries, and not really being able to provide them with any real help. And then I went down to this clinic in Mexico, and, I talked to dozens of people who, had a gun in their mouth yesterday, and then 3 days later, they're giving everybody hugs and, crying for the first time in 40 years, and really letting their guard down in these incredible ways. And I sort of became a transformation junkie, and that part of me that went to medical school came back alive, and I was excited to get to spend time around people who were having these big transformations. So it's not surprising to me that this is bipartisan. I think if you've been exposed to it and you see it, it is very moving.
Yeah. So you have a core value of curiosity, and maybe that is a prerequisite for being a scientist or being a good scientist. And I read another interview where you said you love the down the rabbit hole experience. And here's something you said. I think part of the reason psychedelics are so able to enchant people is because they bring back that wondrous curiosity, that joyous, let me just follow this rabbit hole feeling, and it's wonderful. I wonder how doing this science kind of shapes the way you move through the world.
Yeah. Well, I think starting with, my first experiences of, awe at the natural world with, seeing these sea urchins at the bottom of the sea with my grandmother, the zoologist in Turkey, all the way up until now, I've always come back to that as the reason that I do science, right? It's not just about psychedelics, it's science in general. And, that is kind of the reason that we did the octopus experiment. At the time I was, struggling to get funding. We had this incredible discovery, which I knew was going to change the world, about critical periods, and nobody would, fund me, right? Like I had private foundation money, but the NIH was like, no, psychedelics will never be used for therapy. You're dreaming, go study oxytocin. And I was like, intranasal oxytocin doesn't cross the blood-brain barrier. Why would I study that? That's terrible. And so I was very frustrated. And I had, people like Roland Griffiths, who's, was an elder for me and a mentor, informal mentor for me, saying, oh, just,
Johns Hopkins.
Yeah,
right?
Johns Hopkins. Just, rejigger your application and make it sound like you're studying the bad effects of psychedelics, and they'll give you the money. And I said, no, if we're right about this, I want to get credit, I want to get credit for having this idea, 10 years ago. And so I just wasn't getting funding, and I was getting to the point where we were going to have to close down the lab because I just couldn't pay for people. And so kind of as a last-ditch thing, I was like, well, I got a little bit of money left. Let's do this octopus thing. And I was already kind of down the rabbit hole on octopuses anyway, when a collaborator of mine at Woods Hole called and said, we have 7 octopuses. Do you have any experiment that you want to do on them? And I was like, yeah, ship them down. So he FedExed them down. He got on a plane. He came the next day, and we took like baseline measurements of what they're like, in the tank.
And this was an especially combative, antisocial species of octopus.
Yeah. So octopuses, even if you've seen my octopus teacher, don't believe it. They're not friendly. They are not cuddly. They are vicious predators and very asocial. And so if you put 2 of them in the tank together, they will normally kill each other. But when we gave them MDMA, they did not. So they spent significantly more time around the other octopus. And this was a huge surprise to us because, we diverged from octopuses over 650 million years ago. They don't have any of the brain regions that we think of as being related to psychedelic activity. So they don't have a cortex. They don't have a default mode network. They don't have an amygdala or a nucleus accumbens. And yet, at the molecular level, they're similar enough that the binding pocket for serotonin that MDMA binds to is conserved. And so they're able to have this effect. And what it suggests is that serotonin has been acting as a molecule that encodes social behaviors for a very long time, and that all of these brain areas and this anatomy is just sort of secondary, an accident of evolutionary history. And I got to tell you, this experiment kind of knocked me off my seat for a while because, you know, I'm somebody who does circuit mapping. I do a lot of, you know, track tracing between different brain regions to figure out the circuitry. And this was really saying, no, that's not really the mechanism that you think it is. And so I always go back to that. The way you discover the really big things is not by doing the careful next experiment. It's by asking, I wonder what would happen if, right? And taking those big risks because you're just curious and you're just following the joy. And so I think that's true for all of my best discoveries have always been that way. And, you know, that includes from when I was a child to right up until this day.
Gul, thank you so much for what you're doing and for this conversation.
It's been a pleasure. All right, thank you.